Design add and search words data structure. Design a data structure that supports adding new words and finding if a string matches any previously added strings. Okay, so when we look at the XML in our, this one is just instantiation, and then add words, we add BAD, we add DAD, we add MAD. When we search PAD, there is no PAD, return false. BAD, yes. Dot AD, there's a lot of dot AD, right? Whatever the first character is, if it's end with A and D, we return true. Whenever the word is, if the word has 3 characters and if the first character is B, we will return true. Okay, so the data structure I'm gonna use just like tree. It's also called like prefix tree or trie, TRIE, trie data structure. So I will use that prefix tree structure. Prefix tree lot is the same. Okay, we will have a root. We have 26 children from A to Z, and then every single child will have another 26 children back. So in that tree, every node in that tree will have 26 children for the maximum. Okay, when we use a dictionary or something, we can reduce the size of the children, but I'm gonna use the array, so we will have the 26 length of that array as a default. Okay, so I will have the node class to save the to use in our applications in our word dictionaries. And then in this node I will save 2 values. The first attribute is if this the end or not. If it is, so it's going to be boolean value, and then the children, as I said, I will save an array. Okay, so in my constructor I will instantiate my boolean value with false, and then child is gonna be new node array, right? So the array length is gonna be 26 because we can have A to Z, right? There is no uppercase, so we will think only lowercase. To know the index lemma, we will get like minus small letter A. So if the A is coming, we will minus A. So 60, for example, if it is 65 as equals, so 65 minus 65 is going to be 0, and we got the index number to point to my array. Okay, we have the root value, and then we will instantiate that root new node for the first time, and then it will have 26 children, right? So when we add the words, we have to loop every characters in the string, right? So we will have a pointer node, root node, right? Okay, and then for every character in words, because if it's string, we need to change to our char array, and then we will loop every characters in that words, and then we will add. Okay, and then we will ask the root, hey, the root or the current node, hey, the current node, do you have any children in that do you have any children C like that this character, do you have any children which is this character, right? So at the time we will need the index, or I will change the index number from character, right? So index number. Okay, if the array index 0 is not empty, that means a node is already in that tree. Okay, so we will check node dot child, right? Char index is being null, that means there is nothing yet, so we will add a new node to the child. Okay, so we know that if a node is saving in the roots array 0, it's A. at the array index 1 is gonna be b. Okay, so and then we will go down to the next node, right? And then we will add everything, and then at the end of the node we will change its end value is gonna be true, right? Okay, when we search, I will use a helper function. It's gonna return boolean. I will call such helper, and then in that I will accept a node and a string words and integer index. This index is for the words. When we look for the BAA, it's gonna be, for the first time, it's gonna be 0. Okay, so to call this function, return, or call this function, the index is gonna be, for the first time, it's gonna be 0, and then words, this words, and then this one is gonna be root for the first time. Okay, and then I will return the result of this helper function. Okay, so we will check. In this case, we will have the base case if the node is null or not. If the node is null, oh no, we don't have to do anything, right? If the node is null, return false. What if the index is out of this word's length? That means we need to check only the previous the nodes is and value, right? So if index equal words dot length, return no dot is end, right? So if it is not, we will have the real logic for the session. Okay, so we will check this words at the index this word. Okay, we will check if word text equal dot or not, because if it is dot, we need to check whatever it is, we don't care. Only if it has chimes, we will return. Only if it is chimes. If for example, if we look for this one dot, that means the root should have some chime. That means no rows should be empty. If only a row is having a node, oh yeah, we are not checking the other rows. We have the chime, so that's okay, right? Like that. So we will loop every challenge, right? For each node, it's gonna be, for example, it's gonna be n. There is no n yet, right? And root node dot chime, right? So only if we will call this recursive function, we will give this node and then word and the index plus 1. If there is a node, we will return true, right? If it is dot, we don't have to check if it is equal to some characters or not, right? Okay, only when it is not dot, we need to check that character is equal or not, right? So we will need a character code like that, and then we will return root, not root, here this node, right? This node dot chime character index. For example, if we are looking a, if the a room is not empty, that means we have a and then the other recursive function, because we cannot stop here, right? We need to check if there is other values or not. So we wait. Okay, this one is okay. Keep looking for other characters from this word. So we need to child chime. We need to go down the tree, and then what's gonna be the same, and the index is gonna be +1, right? So if there is, we don't we cannot return from these cases, we will return false, because well, there is nothing. which will be the same with this word. Okay. Okay, let's see which is missing. Okay, C doesn't. Okay, C. Oh, there is no C here. Okay, yeah, I just copy. I really like to copy here. So what index, right? The correct is gonna be this one. Okay. Okay, cool. I'm gonna submit this one. Which one is missing? Okay, cool. So that's it. Thank you.